This is Ruth Guthrie presenting a module on data warehousing, data marts, and data integrity. Here's some data from a data warehouse project at Rensselaer Polytechnic University. They wanted a data warehouse to help them with admissions and financial aid. Their goal was to attract the best and brightest and retain diversity, balance, geography, and manage financial aid. The ultimate results were that they invested $1.2 million initially. The cost annually to operate the system would be $537,000. The savings that they got by improved data analysis was $820,000 annually. Savings in financial aid and awarding financial aid in a better way was $500,000 annually. I guess that means students got less financial aid, so how could that be better? And their savings in labor for reporting was $320,000 annually. Here's a screenshot of the Cal Poly data warehouse page. I used to be department chair of the CIS department, so I had access to a certain view of the data. So you can see, depending on what term it was in business administration, I could see things like what students were active, what students were applying, class enrollment, Dean's List awardees, degrees awarded, enrolled student report, etc., etc. But it's a giant data repository that different people at the university have access to. A data warehouse is a collection of several databases. It is used to aggregate a lot of data for decision making. The databases can be internal to the organization or external. Data warehouses offer drill down capabilities, so someone can look at data at a very high level and then drill down into the data to see more in-depth detail about it. The benefit is that the aggregated view helps managers focus on managerial decision-making instead of operational decision-making. Yet, finer detail in the data is available if necessary. Also, combining data in a data warehouse can give managers a view of the data related to other things that they may never have had access to before. If you're looking at a specific type of cancer, it might be very telling to overlay that data to a geographic map. Then, if it's an environmental problem causing the cancer, say proximity to a coal mine or something, it should become very apparent from the combination of those two things. Time for another IT stick diagram. Here is a representation of a data warehouse from datawarehouseforyou.com. I've changed it only slightly to include external data sources. At the left, we have external data sources, operational systems, ERP, CRM, and flat files that are going into a box called ETL, or extraction, transformation, and loading. These are three database functions that pull data from one database and put it into another. It is the tools used to create the data warehouse from the individual databases. In the data warehouse, metadata, summary data, and raw data are present. Raw data is at the bottom level. It's the original form that the data was collected in. Most managers do not need to see this. Summary data is aggregated or summarized data that succinctly shows what is contained in the raw data. Metadata is information about the data. This could be when the data was collected, where it was collected from, or information about the format of the data. Coming out of the data warehouse are OLAP analysis, reporting, and data mining. OLAP stands for Online Analytical Processing. In a few slides, I'll show you a data cube. That is what OLAP is. Reporting is ad hoc reporting that people request out of the data warehouse. Data mining refers to the exploration of the data to gain insight into business problems. We'll talk more about this soon too. A data mart is a subset of a data warehouse. Using a DSS engine, DSS stands for Decision Support System, parts of the data warehouse are stripped out for use in specific areas. A data warehouse is a giant repository, so using it can be complex and slow. Giving a subset of the database focused on context and use can make the data faster, more relevant, and easier to use. For example, the sales data mart might not need all the information about employees or manufacturing to give valuable insight into sales management. This is an OLAP cube or data cube. The cube is intended to represent multidimensional analysis. The axes are labeled product, store, and advertising campaign in this picture, showing that you have information representing the data at several data points. I can look at store E for all products. I can look at store E product A versus product D. I can look at the success of product C over all 3 advertising campaigns. It gives me a variety of ways to examine the data. That is where slicing and dicing comes in. A slice in the OLAP cube represents, in this case, the left, store C over all products and all campaigns. It physically looks like a slice out of the cube. On the right, dicing is product B, store B, campaign B. It is a specific instance in the cube, and it physically looks like a die. So questions we could ask using drill down types of analysis might be, what store is the most productive and what products are the best sellers at those stores? What clinics need the most blood during which time of year? Which advertising campaign was most productive in which areas? Or what elements are decisively different between my worst performing and my best performing stores? One thing I've hinted at in the past few slides is the idea of information granularity. At a low level, information granularity is high or very small. I remember this by thinking it's highly granular, like sand, small pieces of sand. At a high level, information has low granularity and there's less of it. Think of yard versus foot versus inches. Inches, the finer measurement, has high granularity at the lowest level. Also, all sales versus sales per region versus sales per store, or kids with the flu versus kids with the flu by region versus kids with the flu by region and age. Granularity is how far you can dig into the detail of the data. Data integrity means that you trust the data you are getting from the data warehouse. But data isn't always correct. Sometimes it's erroneous or incomplete. If you base a decision upon bad data, you run the risk of making a bad decision. High-quality data can lead to better decisions or, at the least, more informed decisions. Many sources list 5 or 6 characteristics of high-quality information. 5 listed here are accuracy, the data is correct, completeness, all the data needed is there, consistency, meaning the data is uniform, like a phone number has 10 characters, never any other length, uniqueness, to have value the data must uniquely inform the company, and timeliness, new and current data is better for current decision making. Data cleaning or data scrubbing is the process of fixing a database so the data is clean or without error. To scrub the data, we try to get rid of several things, like missing data or attributes. Perhaps a person didn't fill in all the information. Redundant records. Maybe a customer has 2 records for billing information, causing confusion when an item is purchased. Missing keys. A missing key makes it impossible to link the data to other tables. Erroneous or incorrect data needs to be fixed. For example, a spelling error in the last name or the wrong zip code with a customer address. Have you ever set up a fake account on some website so you could gain access to a service for free for just a short period of time? That account probably still exists and is a dead account in the company database somewhere, like your old MySpace account, or like signing up for a free mobile app generator just to try it out. Data scrubbing might get rid of these dead customer accounts. Information accuracy costs money. The more complete and accurate the data is, the higher it will cost. It takes resources to collect, verify, and fix data. Another question, maybe a more relevant one, is what is the cost of not having high-quality data? And the cost might be that you have to redo things, you make bad decisions, or you are in danger of having failed processes. Getting the data right early in the data collection phase is really important to having a database with high integrity. You may have noticed this when you're entering online forms, that there are features set in to keep you from making an error. For example, the @ symbol. If you're filling in your email address and you don't have the @ symbol in, then they know it's not an email account, or they might even email you a message before they activate the account. This ensures you're using a valid email address. In online forms, there's also often a red asterisk indicating this is a required field. If the user doesn't fill in all the fields with the red asterisk, then they're not entered into the database. They have to fill in that data to have their valid record be counted. Also, setting limits on form fields is a way to ensure correct data is being entered. For example, if someone's entering a zip code, then you check to see if it's 5 numerical values. If it's not, and someone's just typing in ASDF space, then the form is, of course, rejected. This is the end, so let's answer a few questions. Is a monthly sales report an example of highly granular information? A monthly sales report? No. It's kind of in the middle, so this was kind of a trick question. It's more granular than a yearly sales report and less granular than a daily sales report. What is that OLAP thingy? Remember OLAP, such an odd term, and what it stands for? Remember Data Cube, with the ability to slice and dice. It's the OLAP Cube. Why would anyone use a data mart instead of a data warehouse? A data mart, remember, is a subset of a data warehouse. It's used for more focused purposes. So if there's a functional department that wants to use a subset of the data warehouse, a data mart, it would get part of the data from the data warehouse, not the whole thing. And the reason they do this is because it may be faster and easier to use. That's it.